Following on from the previous two videos, we got to this stage here where dx is given by this and dy is given by this. Well, so what this means is that suppose your particle is currently here. If you give it a small increase in the angle, so if you give it a small increase in the angle, so if you give it a small increase in the angle d theta, then if you get d theta and then multiply with this, then the whole thing here will tell you how much the particle has moved in the x direction. So currently your particle is currently here at the moment. If you give it a small increase in the angle, get the small increase in the angle, and then combine it with this thing, then the whole thing here will tell you how much the particle has moved in the y direction. So a small increase in the angle, then this whole thing here will tell you how much the particle has moved in the x direction. A small increase in the angle, combine it with this thing here, then it will tell you how much it has moved in the y direction. So now that we know dx and now that we know dy, we can work out ds by using Pythagoras. So by using Pythagoras, ds squared equals dx squared plus dy squared. So what it means is this. In the previous video, we worked out dx and we worked out dy. So if you want to know ds, then you got to square the dx. So you got to square this whole thing, square the dy, square that, and then take the square root of the sum of the two. Okay, so we want to know ds here. So let's square this and let's square this. So from here we hang on. So from here we've got to square this. So squaring this, so imagine this as being one block and this here as being another block. So when you square this, you're timesing it by itself. So d theta times with d theta, that will then give you d theta squared. And when you square this, it will actually give you this thing here. It will actually give you this thing here, because yeah, think about it. If you square this, it will give you this thing here. Okay, think about it. And then if you square this, then it will give you this thing here. And then you've got your d theta squared. Well, anyway, dx squared equals this whole thing here. Dy squared equals this whole thing here. Remember, up here we've got to add the two together. So adding the two together. So currently we are here at the moment. We've got to get this, add this. So this, add this. Meaning we've got to get this whole thing added to this whole thing here. Okay, so if you look at this here, hang on, let me think. So let's just concentrate. So here we've got one block multiplying with another block, and then we've got to add it with this block here. And also with this block here. So if you add the two together, if you look at this, hang on. So basically, if you add these two together, hang on. If you add this and this together, it will give you this. Because if you look at this here, f prime squared. Here you've got f prime squared. The only difference is that you've got a cos and you've got a sine here. So factor out the f prime. The f prime squared. So factor out the f prime squared, and here you've got cos squared plus sine squared. So cos squared plus sine squared here. And then so combining these two will give you this. And then if you look at this here, this is exactly the same as this, if you think about it, because look, cos squared, this here is cos squared, sine squared, this here is sine squared, f theta is here, f prime theta, 2. So these two are exactly the same, but the only difference is that you've got a minus and a plus. So these two will cancel out. And then if you look at this here, you can factor out the f of theta squared, So factor out the f of theta squared, and then you've got sine squared, cos squared. So remember, this becomes 1. This here becomes 1. So this whole thing here will simply be this. So remember ds squared equals dx squared plus dy squared. So later on we will need to take the square root of this, square root of the whole thing. So currently we are here. Take the square root. So remember this here equals ds. Okay, so take the square root. That will then give you this. And then remember, if you have a square root of a times b, that's the same as root a times root b. So here, well, imagine this as well, you can take this out. So it's like this. So it's like square root of the whole thing, and then square root of d theta squared, and then this thing here just becomes d theta. So anyway, from here it would then take you to here. So this thing here, don't forget, is ds. Okay, because ds squared equals dx squared plus dy squared. So if you square root both sides, then ds equals this. So well, this thing here is ds. Okay, so ds equals this. So if you sum up all the ds's, then that will then give you the actual path. So well, what this statement means is this. Hang on. Well, so if you want to know the actual arc length, is you taking the integral of this whole thing here from one angle to another angle. So what this is saying is this. Hang on. What this is saying is this. We know dx, we know dy. So from this we can work out ds. So hang on. So when you give it a small increase in the angle d theta, then this whole thing here would represent ds, the actual length. And then if you give it another increase in the angle, if you give it another increase in the angle, then this whole thing here will give you another ds. If you give it another increase in the angle, then this whole thing here will give you another ds. If you give it another increase in the angle, then this whole thing here will give you ds. So basically you're summing up all the ds's here. So the actual path from one angle to another angle is given by this. Okay, so we're going to make use of this. So the whole arc length, the path along here is given by this. So it's just a matter of you it's just a matter of you using this formula. So we're going to make use of this. Okay.